So shall we get started? Okay. So hi everyone. So let me first briefly introduce myself. I'm Jun Wei. I'm an assistant professor in the Department of Biostat in the Harvard School of Public Health. And my major research interest is in the application of statistical model, machine learning, and AI, artificial intelligence, with applications in graphs, networks, and medical imaging data. So here I'm giving a lecture about how would we apply deep learning, especially in the applications of imaging data. So in computer science, people usually call it computer vision. So in the sense that we are seeing pictures and images everywhere. And so as a human being, we can understand like, oh, this is a cat, that is dog, but we hope the computer or the algorithm can do the same thing as human being and even more complicated tasks. So in today's lecture, I'm going to give you the brief idea about how does that possible and how the deep learning is applied in such applications. So I'm not sure if it's what you have been doing in the previous lectures, but I do encourage you to interrupt me. Just unmute yourself if you have any question. Both because of, I think, first, that's easier way to communicate. I don't have to read your question from text, but just hear from you. But also, like when I make this full screen slides, somehow I cannot really see the mouse, so it's a little bit hard for me to click the chat in the Zoom. So I think the easiest way just is unmute yourself and ask questions. So let's get started. So as I just mentioned, the deep learning, probably you also have seen in the previous lectures, has been applied to a lot of applications in computer vision and for your main task in this summer school, self-driving car, AlphaGo, Super Mario, and other lot of apps you are using in your smartphone, for example, Google Translate, etc. And many of these applications essentially is the task about process images. Because even you are playing Super Mario computer games or you want to translate a text, the input of these kind of tasks are images, right? So in that sense, understand how to process an image is a very important task in many machine learning or AI jobs. And deep learning actually has contributed a lot into these tasks. Before we talk about how deep learning may help to these tasks, we may take a brief look about the history of deep learning. So deep learning probably has been popular for decades, starting from maybe the first 10 years of this century. But actually, deep learning has a very long history. It can even be traced back to when computer was invented in 1957. So during that time, the computer is actually really a very huge machine, which may take the entire room, and its computing power maybe just as limited as some calculator or even worse. And during that time, the so-called neural network, artificial neural network, has already been invented. So this first artificial neural network was built upon the computer called Mark I perception. So it is kind of pity that you cannot attend the summer camp in Harvard, because in Harvard, if you visit the Science Center of Harvard, there's really actually a computer model in the Science Center building called Mark II, which is one of the first generation of computers. It's just like shown in this picture. It's a huge machine, and people need to connect wires to wires from one unit to another. So probably during the past lectures, you have the brief idea about the neural network are basically connecting different neurons or different numbers together, just like the image we have shown here. Probably have seen it multiple times. But during the 1950s, it's not just like you code these numbers or units by like multiplying numbers or adding numbers. They're really literally the wires connecting different units to build the real network, neural network. So this, I think, is a very interesting fact of history which has been forgotten. But I just want to let you know that neural network is not some very new idea. People actually, scientists have like invented this model for years because it's a very natural mimic of the connections of neurons in human being brain or in the nature. But what makes this first generation of neural network not that popular, or people forgot what happened before, is because the speed or the scale of the network. Because during that time, since you really need to connect wires to wires to build the neural network, and it makes the computation very slow. And it was dominated by another algorithm or another types of algorithm called the support vector machine during the 1990s. So the first generation of neural network becomes not that popular. It's due to the computation resources limits. But after the 2006, George Hinton and all the other computer scientists, they have built the deep neural network. On the one hand, scientists actually really contribute a lot to improve the model, but more importantly, thanks to the development of the computing power in hardware, we now can actually handle large-scale network, such that like even the computation is in a great scale, but our current computing power can process that. So this is the brief history about the development of neural network, its ups and downs and up back again. So I want to use this story to tell you that computing, sometimes the model is correct, or maybe it's also a very good algorithm. It was invented many years ago, but we need to match the algorithm with correct computing resources. And in imaging, this is especially important because imaging is usually complicated and computation is a very important part of it. And we need to use a lot of computing resources, and thanks to the development of hardware, now everything is possible.